Question number 11. On diagram 1, sketch the graphs of y is equal to x into 3 minus x and y is equal to x into x minus 2 into 5 minus x, showing clearly the coordinates of the points where the curve crosses the coordinate axis. So, let's begin by sketching the first curve, y is equal to x into 3 minus x. In order to sketch the curve, we need to find the coordinates where it crosses the x and the y axis. So let's begin by finding the coordinates where the curve crosses the x axis. So we can do this by equating the right hand side of the equation to 0. We have x into 3 minus x, which is the right hand side of the equation. We equate it to 0. Therefore, we have x is equal to 0. And 3 minus x is equal to 0. We have 3 is equal to x, or x is equal to 3. So we have 2 points of intersection. One is the origin and one is x is equal to 3. Okay, so let us sketch the curve. Our points of intersection are 0, 0, which is the origin, and 3, 0, let's sketch the curve. Okay, so this is roughly how the quadratic curve would look. Now, some of you may be wondering, it could even look facing upwards, but the reason why the curve is facing downward is because if we multiply the equation, we have y is equal to x into 3 minus x, and if we multiply the equation, we have y is equal to 3x minus x squared. So we have a quadratic curve where the coefficient of x squared is negative. So whenever the coefficient of x squared is negative, the curve will face downwards. Alright, moving on to the next curve, we have y is equal to x into x minus 2 into 5 minus x. Again, let's begin by finding the points where the curve crosses the x-axis. So let's do this by equating the right hand side to 0. We have x into x minus 2 into 5 minus x is equal to 0. Therefore, x is equal to 0, x minus 2 is equal to 0, and 5 minus x is equal to 0. We have x is equal to 2, 5 is equal to x, or x is equal to 5. So here we have the curve crossing the x-axis at the origin, x is equal to 0, at x is equal to 2, and at x is equal to 5. Let's sketch the curve. So the curve is crossing at 0, 0, at 2, 0, 2, 0, and 5, 0. Okay, now a cubic curve may start from the lower side and finish like this, or it may start from the upper end and finish like this. So before we sketch the curve, we need to establish what is the direction of the cubic curve. In order to do that, we can take a positive value for x. We know that when x is positive, it's going to be towards the right hand side of the origin. So When we take a positive x value and plug it into the equation, we will get a y value. If the y value that we get is negative, then our curve will start from the lower side and it will go like this. Alright? On the other hand, by plugging in a positive x value, if we get a positive y value, our graph will start from the upper end. So let's take the value x and plug it into our equation. We have y is equal to x into x minus 2 into 5 minus x. Plugging in 10, we have 10 into 10 minus 2 into 5 minus 10, and we have y is equal to negative 400. This means when x is positive, y is negative, which means the curve will start from the lower side. So let's sketch the curve. Okay, so this is the way our curve is going to be seen. We have drawn both the sketches separately for better understanding, but in part A of the question, we have been instructed to have both the sketches on the same diagram. So here we have them on the same diagram. There is a very important point here. Now, some students who have drawn their cubic curve may have had their cubic curves moving like this, which means somewhere along the quadratic curve. But you need to keep in mind that somewhere down the line, your cubic curve will intersect the quadratic curve. So, if you've not drawn your curve intersecting immediately, you need to bear in mind that somewhere down the line, your curve will intersect the quadratic curve.